Fluids, Day 2, Part 3. What percentage of a floating chunk of ice projects above the level of the water? The density of ice is 917 kilograms per cubic meter, and the density of water is 1,000 kilograms per cubic meter. So I've defined the terms WB, weight of the iceberg, W sub W, weight of the water displaced by the iceberg, V sub W, volume of water displaced by the iceberg, V sub B, total volume of the iceberg, and V sub, the volume of the iceberg submerged. The first thing we can say is, since it is not accelerating up or down, the weight of the berg is equal to the buoyant force, but we know the buoyant force is equal to the weight of the water displaced. Weight of the berg, density of the berg, times the volume of the berg, times G is going to be equal to the density of the water times the volume of the water displaced times the acceleration due to gravity. We can then solve for the volume of the water displaced. Since G's cancel. And the amount of water displaced is equal to the volume of the submerged part of the berg. So then I can say that the percent of the berg that is submerged would be the volume submerged over the total volume. I'm solving the equation above for V sub divided by V sub B, and that's equal the density of the berg divided by the density of water, and that is equal to 917 over 1,000 as a percent. That's 91.7% submerged. Now, if I want the part above the water, I can say 100% minus 91.7 equals 8.3% of the iceberg above the water. Example 4 has to do with a raft floating on a river. It's constructed of wood. It gives us the density of wood is 600 kilograms per cubic meter, and it gives the surface area of the raft and the total volume of the raft. It's placed in fresh water. To what depth is the bottom of the raft submerged, and how much more weight could be adjusted or added so that the top of the raft is just at the level of the water? What I can say is the raft is in equilibrium. So I've drawn a free body diagram, and I know the buoyant force minus the weight of the raft is equal to 0 because it's not accelerating up or down. Buoyant force then has to be equal to the weight of the raft. And the weight of the raft is the density of the raft times the volume of the raft times the acceleration due to gravity. And the buoyant force is equal to the density of the water displaced times the volume of the water displaced times the acceleration due to gravity. So, the density of the raft times the volume of the raft equals the density of the water. Now I'm factoring out acceleration due to gravity. Those cancel. Times the volume of the water displaced. Now let's see what the volume of the water displaced is. Well, the volume would be the area of the raft times the depth to which it sinks. So I can solve for D. It's rho V of the raft divided by rho of the water times the area of the raft. And now I can plug in numbers. The density of the raft, 600. Volume of the raft, well, that was given as 0.6 cubic meters. Density of water is 1,000. And the surface area of the raft, 5.70. So the depth to which it sinks is 0.0632 meters. So D is the depth of the raft that's submerged. To find out how much more weight could be added, we need to determine the weight of water displaced by the total volume of the raft. So if the total volume of the raft were displaced, that would be the new buoyant force. And that would be 1,000. Total volume of the raft, 0.600. So the whole thing is going to be just underwater times 9.8. And we get 5,880 newtons. Now, let's find the weight of the raft. The weight of the raft is its density times its total volume times the acceleration due to gravity. And that would be 600 times 0.6 times 9.8. And that gives us 3,528 newtons. And so what we have right here, if it's totally submerged, here's the raft, 3528. Totally submerged, the buoyant force would be 5,880. So we need another added weight here. I'll call W. So W is simply the difference of the weight of the water and the raft and that would give us 5,880 minus 3528 for a total of 2,352 newtons added weight that we could put on there in order to totally submerge the raft. I'd like you to try this last problem. It has to do with a block of uniform density that floats in water, and 60% of its volume is submerged. So now we're going to place that block in a container with a fluid of density 900 kilograms per cubic meter, and I want to know what portion of the volume would be submerged while floating. And the answer is here, so have fun with that one, and we'll see you on day 3.